Hello everyone, welcome to VKS YouTube channel. In previous video, we discussed all about the simple linear regression basic part. In this video, we are going to discuss all about the practical implementation part of the simple linear regression. So basically, I'm just using the Jupyter Notebook. And here, I have taken one of the data set and that data set contain height and weight. As same things I just explained in that previous video while taking the example of the weight and height. So let's start the implementation part. So before importing the file and analysis the data, so we have to import the necessary libraries. So we have to import the necessary libraries. So first of all, so here we can just mark it as one first step. And now we have to import our first libraries, import pandas as PB, then import compile as LP. If it will be required, then import matplotlib dot pyplot as PLT. Import P1 natural service. So these are the libraries, necessary libraries we have to, basic libraries we have to just import faster. So let's just, if we have the data set, we have to just load it. If in libraries, we can directly also read that file, which is also marked as a headline, the read and load of the data set. So here, I'm going to just load the data set with the help of the pandas. So I'm just giving one of the data frame variable name as a DA. Then with the help of PD, like pandas, dot, I'm going to read that CSV file. My file is in CSV format, so CSV. As I have to just keep the name called. Here you can just go and check the name. So you can just find this CSV file in GitHub account, my GitHub account. You can just go to my description part and you can just download it. Now, this is the data set and you can just check it. So let's give that head part so that it will be show you the first 5 elements. So these are the first 5 elements. So right now, so we successfully load the data and also read that one. So as we have having the data set, so let's just visualize it. Okay. So we are going to just visualize the data. Visualize the data. So here we have to just visualize the data, right? We have to just visualize the data. Now, in this visualization, what we will just get to know the relationship between that weight and height, right? So here with the help of the matplotlib, we have to just draw the scatter plot. And that one is what, like there is a one variable that's written that weight, and then in y-axis part, we will just take that height, right? Height. So here, this one is the height. Let's remove this part. Good. So next, we have to just label it plt.xlabel. So in the X label part, we will just give like, for example, you are having that doubt, what exactly the label part. Now, if I will just execute this part, see, if I will just execute part, so it will like, okay, so there is some error, minor error is there. So it is what exactly it's showing one of the graph, right? So label in the sense what, like this side is X and this side is Y. We have to just say in X-axis, either it will be weight or height. In the Y-axis, either it will be weight or height. So that's why we have to mention that weight and height, or we have to just label it for the better understanding. So that's why PLT dot X label, like in the X-axis part, down of the X-axis. So we have to just write X label what the weight. And then PLT dot Y label, okay, Y label. So that one is the height. Now, if I will just execute this part, now see, just error this one, just remove that one. Now see, the weight and height is written, right? So this is the what the plot or the data point it is given, like the data point, which is otherwise known as the, you can say that actual value, the actual value is here. So these values which is split like here, okay, split like here. So the first one is 45 and 120. 45 then 120. Just look at this point. This one is the 45 and here 120 there. So likewise what? So that is what data point is split according to it, right? So now we can just go for like X and Y. So you have to just go for that X. In that X axis part, what we are just taking, and the Y axis part where we are taking, right? So here, because we have to just train our simple linear regression model. So here X is equal to df dot I log 10, 0 is to 1. So here basically, what do you mean by the I log? So it is the method which will be allows the integer based indexing, And here I just denote that only the colon part, because it select all rows. In a column, in a specific column. And now the question is, why I just written 0 is to 1? Then 0 is to 1 means like it will be select the first column. It will never include the second column. It's like what? So first of all, it will select on the weight part. It will never go for the height part. So that's why I just mentioned the 0 is to 1. Clear? Next, PLT, not PLT, in the Y axis part, in the Y part. So df dot ilog, you already know the ilog means, and then integer. So we have to select that one, select rows, and then we will go for the height. For the height case, so we are going to the negative one. Now if we'll just execute successfully. So right now, let's go for that X part. So if I will just show you the X part, and this is the X part. And if I will just show you the Y part, now see the Y part. So here, this one is the X and Y. So as total, like if I will just show you what exactly the size of or the shape of my data set. So this is the shape. Total 23 is there. Like if we'll just include the 0, so it will be what? 22 plus 1 equal to 23. It means what? 23 data is there. So right now in this data set, I will just split like some of the data which will be what? I will just hide that data for my new model. That one is the linear model. So that's why I will just split the data into X trend and X test, and the Y trend and Y test form. right? So here, first of all, for that case, we have to what? Select the model. Because of model selection, we are just doing it. So right now, from the help of the sklearn, so I have to do the model selection. And here I have to input what? The train and the test. And we will just what? We'll just split it. So here, first of all, we have to make a xtrain format. Then again, xtest. Like there is a 23 data is there. In that 23 data, so some of the data will be go for the xtrain part, and some of the data I will just hide in the form of the xtest. Now, there is a y train and there is a y test. Whatever data you are taken from the xtrain part, the answer of that data is in present in the y train part. And whatever data you are just hiding in X test part, so that same data which is present in the Y test, it's like the answer of that X test will be present in the Y test. So hence, we'll just write, and we have to just what? Successfully train and test. We will successfully split it. Now we can just write X, Y, and we are taking how much test size you want to take, like how much data you want to just hide for the upcoming model. I want to just hide only this much. Okay, so it will be a random. So that's why I'm just writing. So here, this is the thing. So now here, let's call or let's initialize the linear regressions. So right now I have to initialize the linear regressions. Okay. So here from a sklearn, okay, linear model, okay, linear model. So you have to import what? We have to import the linear regression. We have to import the linear regressions. And now let's execute this part. It's showing some of the error. Maybe there will be some error is there. So here it's showing the can't import the name called the linear regressions. So here, because of this, like capital letter I'm not written, so that's why it's showing. Now it's successfully executed. Now, so here I have to just initialize it. So whatever things I just written here, just copy it. And now see what exactly it's showing. So now if I will just click the regression, like REG part, now this is the linear regression part. Now I will just feed that one, like whatever train, like whatever question is there, I will say as well as for that same question, I will also provide the answer, like in the form of the y train. So that's why I will just write it regression dot feed, and I will just write x train and y. Now I successfully fit that regression, linear regressions. Now here, if I will go for that X test, like whatever data I already hide in the form of that X test. Now, if I will just check it, now see, these are the things. These are the data I just hide. And if I'll go for that Y test, now see Y test, and these are the data I just hide. Means if I will just provide to the model 45, I want to check what exactly the model is predicting. Whereas the actual answer of that one is, if the person's weight is 45, the height of that person should be what? 129 centimeter. Right now, we have to check with the help of the linear regression, if the person age is 45, then what exactly he just what? Predicting the height of the person. So for that case, I'm just writing one code, regression, we have to predict it, regression dot predict. So here, x test dot log and 0. Like So here it will be select. Why I'm just writing I log? Because to select all the rows. So here, sorry, all the integer based indexing. So here 0 in the sense what? Like I will, let me just complete the code. Then after that I will explain it. So values dot receives 1, 1. Now see, if I'll just execute this part. So here, as you already know that this one, it will be allow you the integer based indexing. And this part is nothing but the what? It will be start from the 0, like it will be start from this part. If the weight part will be 45, then what exactly the value will be? Okay. The why I'm just written this dot values because it will be this part will be help you out to extract the value from that column. And here the receipt 1 comma 1 because of like because of 2D because of 2D array, right? So right now it is coming what? 1, 3, 1. So if you want to just check it like likewise, whatever data is there, I want to just check for the second one. I want to check for the second one because I'm just using the indexing part. Okay, here. First one, 0, second one. Now again, I'm just checking it and what exactly the answer is giving 4131 because of what? Because of 45 is there. But what exactly our output is it? 129. So it is not correct, right? It is not correct. Now, if we'll just go for that, if we'll just go for that, the one next part, so it is giving what? 120. It is giving 120. So it means what? So here it is not giving the exact answer. Here model is predicting these things and which is quite very you can say that a very long distance towards like our actual answer. So here let's check it likewise. So if we'll just go for that two, then so I have whereas if I will just go for the 56, so the answer is 140, but my model is what? Predicting 142. So it is quite like good. Like right now our model is what? Predicting closer to the actual answer. Clear? Now if I'll just keep 3 and now if I'll just execute. Now what exactly 380? If the height of the person is 80, now the answer should be what? 163. Now the same things is what? Now our model is what? Now it is closer to the actual answer. Now let's keep 4. Now check it. Now if the models predicting like if I will just provide like 85 data, the height of the weight of the person is 85, then the model the actual height is what? 170, but my model is predicting what? 169.85. So it means what? It is totally closer to the answer. Now we will say that. So as my model is what? Now it is successfully predicting these things. Now, if you want to check out like how exactly this thing is predicting, right? So in linear regression, so we are focusing on what? Like we have to just make a base fit line. If you want to make the base fit line, so automatically the slope and the intercept value will be changed. So now you can just ask me how we will just know that what exactly the coefficient and that intercept value. So here we can just check it like this so that for the better clarity. So here I can just write coefficient like, so what exactly the coefficient value? So this is a 0.9. So let me just store it as a in the y. So as we already know that the equation is what? Y equal to mx plus c or the b. So here the value of slope is what? So here like this. So whereas the aim is nothing but the value of this is. Now similarly go for the intercept. So regression dot intercept value. Now this is the one. This is the output. Now let me just store it in what? So it will be stored in the B. Now see the output. Now, so here we already know like the coefficient and that intercept part. Now, as we already know that as we already know, the equation, the linear regression equation. What exactly the equation? Y equal to mx plus mx plus b. So whereas, so here m is the coefficient, or you can say that the slope, and the b is the intercept value. Now here we will just write what y equal to, for the first case, what exactly our model is predicting 131, right? So whenever the weight will be 45, then it is predicting 131. Will it be like correct or wrong? Like how exactly is this like providing you the output, the prediction answer? Let's check it. So if I will just multiply that 45, like if the person of height is 45, then what should be the height? If the person of the weight is 45, then what should be the height? The height should be what? 13171. Will it be like similar to this one? Yes, this is similar. Get my point? So likewise, if you will just check, like for example, m multiplied, the third part is what? 56. If the person weight is 56, then what should be the height? The height should be what? 142. Now see, it's closer to the 40, because 56 is here and now it's 40. So it is closer to the 50. So now the exact answer, like near to answer coming is what? Like 4. The last one, right? 85. So let's check it. Let's check it. So if the person weight is 85, now what is the height? Now we are just asking to our model, what should be the height of the person? Now we're just predicting what? 16985. So 16985. Clear? So this is the like implementation which will be help you out, like how exactly the model is what behaving, the behind of the mathematics, like you can say that the algorithm part. So now with the help of this practical implementation in the upcoming next video, we'll just know what exactly or how exactly the mathematics is working behind of this implementation part. Now, if we'll just say me here, this is the visualization and I want to just draw one best fit line. So here, I can just plot that one, PLD dot scatter plot, and you can just, it's better like for the setting the time, we can just copy the code directly. The same things I'm just copying. And now, so here I have to plot the regression line. So with the help of the matplotlib, so here, so x based, right? So here again, the regression dot predict x test, and the color would be, I'm just giving the green. I'm giving the green part. Now let's execute this part. Okay, so it's giving error. The module matplotlib.pyplot has no attribute. Okay, PLT, right? Okay, so here, so there will be what? It should be plot. Okay, so let's see. Let's wait. Okay, so there is some error is also coming. Okay, so invalid index error. Okay, so it's not exactly like extracting that value. So because of that problem, so we are just giving the values. Now maybe it will be extract. Yes, it's successfully. So it means what? Based on our data points or the actual value is splitted. So now our model is what? Like create one regression line or the predicted line like this. So this is the in term of like X test. Now, if you want to draw that regression line in terms of the training part, now if you just change that into the training part, now you can just check it out. Now the line is what? Like this. Clear? So this is the things, and Hope this implementation part will be help you out for better clarity for the simple linear regressions. So thank you. And if you are having some of the doubt, so you can just ask to me in the comment box. And if you just like this video, so please do subscribe the VKS Sir YouTube channel and do like. And thank you for your support. And see you in the next video with a new concept.